Alright guys, welcome back to another Math Notes video. We're in 10.1.3 and we're going to be talking about arithmetic series. So the sum of the terms of a sequence is called a series. We've been talking about sequences since integrated 1. They're basically, you can think of them as the integer points on a line. If these terms have a constant difference, meaning they increase or decrease linearly, they form an arithmetic series. So if there's a common difference that form a line, you get a linear equation. It's an arithmetic series. For example, in the series 2 plus 6 plus 10 plus 14, this is an arithmetic series. It's an arithmetic series because we can see that 2 plus 4 gives us 6, 6 plus 4 gives us 10, 10 plus 4 gives us 14, and so on and so forth. So if we were going to write an equation for this, we could say that t of n equaled 4, which is our slope, times n minus 1. 1's our first term, and our value of our first term is 2. So 4 times n minus 1 plus 2 would give us the equation, which would be exactly equivalent to writing it in y equals mx plus b form if you found the 0th term. In other words, we went back 1 to negative 2. That would be 4n minus 2. So you can see then that these are equivalent if you distribute this. That would be 4 times n minus 4 plus 2. The minus 4 plus 2 becomes negative 2 in that situation. So either of those will work for the equation. And this is called an arithmetic series. So more generally, if t of n equals m times n plus b, then it's an arithmetic series where n is the term number, m is the common difference or slope, b is the 0th term, also known as the initial value or starting point, and the related arithmetic series is t of 1 plus t of 2 plus t of 3 all the way to t of k. So our first term is going to be t of 1, our last term is going to be t of k. All right, the sum of this series with k terms can be found by adding the first and last terms and then multiplying by half the number of terms. So here's our first term, here's our last term, and then we're going to multiply by k, and I'm going to split that into k and 1/2. And I'll show you why. So they've given us this graph down here. I'm going to amend the graph a little bit because I like to show this a little differently. It all works out to be exactly the same, guys, so don't overthink it too much. So I'm going to highlight this all gray right here. And we're still basically going to do what they have here. So if we have our first term, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Then I'm going to put another series, it's actually the same series, right on top of it. So that this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I skipped a number somewhere. It was the 10. And 16. And you should be able to see that now we have doubled the area of this original shape. So it's this area that we're interested in, the highlighted region. And by flipping it, I've taken it from sort of a trapezoidal shape to a rectangle. And rectangles are really easy to find the area of, right? Because for rectangles, we just need to have the base, which in this case is k, and the height, which is going to be t of 1 plus t of k, and in this case this would be t of 16 in this particular instance. So if we add those two heights, we're going to get the height of the rectangle. And I'll rewrite it over here. So we would be summing the first 16 terms in this series the way that it's written. So we're going to take t of 1 plus t of 16. That makes our k value 16. So the base is 16. And that'll give us the area of this whole rectangle. And it should be kind of apparent that if we find the area of this yellow rectangle, that we're finding actually twice the area. So we're going to want to cut that in half, the same way that we would cut, a triangle in half when we cut a rectangle in half, we're finding the area of a triangle. So we're going to find the first term plus the last term times the number of terms divided by 2 will give us the area that we're after, this area under the curve. Okay? That's it, guys. Have a